Welcome to micro communication course. Now we see here a measurement of a S parameter. So the S parameter measurement is nothing but what will be the input and output ratio at that given particular port that is to be measured. So to measure the S parameter, we can use directly a network analyzer, and that through the network analyzer directly we will get the what will be the S parameter for the given particular port there. For any component, we can measure the S parameter. So performance of any antenna, if supposed to we wanted to find out, so in that case we supposed to know that AES parameter of that given antenna. So that we can find out what will be the isolation parameter, what will be the impedance matching parameters and all at given particular port. Or impedance can be measured using the dose device. So generally AES parameters are nothing but a complex quantities, and to measure those we supposed to use a network analyzer here. But again, we should know that to measure the given particular S parameter for the given device, that device is supposed to be a ideal, or that device is supposed to be reciprocal with the equal arm length. Okay, so now then and then we are able to find out the S parameters of the given particular uh, component or a device there. So now here we consider the example of S parameter measurement for the magic T. So magic T, it has a four port, port 1. This one is about a main waveguide. Okay, so port 1, port 2 here. Then we have the E arm, so that's why it's called as the E plane T here. This one is about E plane T, and this one is about a H plane T, H T here, H arm and E arm. So both E and H arm are there, so that's why it's called as a magic T here. So to measure this, so if we doesn't have a network analyzer, then how to measure the S parameter of the given particular T here? So for that purpose, we supposed to use a setup or a micro bench setup. We supposed to connect, and then we say have a source, then isolator, then attenuator, one by one component we supposed to consider, and after that, okay, this one we say that a source, then we have source there, then we have a isolator, then attenuator, then your slotted section probe carriage, and then whatever the device under test. That device under test is nothing but a magic you consider. Okay, so now you consider that a magic T here, and then we need to find out a output at each and every term there. So measure the output initially, whatever the source we are connecting, we need to measure the output of the given particular source. So if supposed to we have a reflex piston as a source there, and from that given particular source, so what will be the output that will reach to the given particular T here. So I suppose to say that a V in is nothing but the a source, or for a given particular source it provides the output that is about a V in. Now that V in is the input to the given particular T. Then we consider that whatever the V in we are supposed to be used here for the given particular source from the source. So we use the alternator here to adjust that what will be the input to the given particular device there. Then give input to the any of the port. Give input to the any of the port. Suppose I am saying that input to the port 1. Okay, I say that here I am going to give here the input now. Then we need to measure the output at the all other port here. Suppose I am giving the input to the port 1 here, and I wanted to measure the output at the port 2 here. So in that case, we need to connect the detector at a port 2 and port 3 and a port 4. That port 3 and port 4 is to be matched. Okay, so that's why we supposed to measure the ratios or a voltage using the input and output here. So for that, we supposed to consider that when we are measuring the output at the given particular port 2 here from the port 1. So in that case, we say that that value at this particular port here, we say that because of the input is at a port 1, so we will get the output at the port 2, V21. Similarly, we have the input at a port 1, we measure the output at a port 3. We have the input at a port 1 and measure the output at a port 4. So now if to measure the output at a port 2, this port 3 and port 4 are match terminated. Then if you wanted to measure the output at a port 3, since your input is 1, then all other ports to be match terminated. Port 2 and port 4 is to be match terminated and measure a output at a port 3. Then measure a output to measure a output at port 4, this port 3 and port 2 is to be a match terminated. So this way here we'll get the output, because when we have the input 1, output will be at a 2, because the port 3 and port 4 are match terminated. We supposed to give the input at a port 1, output is at a port 3. In that case, port 2 and a port 4 are a match terminated. So we get the output at a port 4 when we input at a port 1. In that case, port 2 and port 3 are a match terminated. This way we'll get the input. Now next condition, if you consider that if we are giving the input to the port 3, okay, I'm saying that instead of that, I'm supposed to consider that this one is the case here. We have the input to 1. Okay, this one is the condition that the input of a 1. If supposed to be, I'm going to consider that a input at port 3 now. So in that case, if we consider that input at a port 3 here, so in that case, we'll get the output that is a V31, then V32, then V34 here. Okay, so likewise. So 3 is the input, 1 is output, 3 is input, 2 is output, 3 is input, 4 is output. Okay, are you getting? Just like simply, I suppose to consider that here we have the input at a port 3, output is at port 1, input at port 3, output at port 2, input at port 3, output at a port 4. Okay, so in that case, for the given condition, if you measure the output at port 1 while input at a port 3, so port 2 and port 4 is to be match terminated. Similarly here. Okay, similar in this case, similar. So all other cases here, we supposed to consider that the termination, whatever the termination we supposed to consider that it is that is to be other port is to be match terminated, and then find out a S parameter. Okay, so then even if we consider that if we are going the input to the port 4 here, okay, if we are going the giving the input to the port 4, then we need to find out the all other parameters then, and from that we will calculate that a S matrix here. So now we consider that, I suppose to consider that you people understand that how to measure the input at port 1, port 2, port 3 likewise. I just taken the example of 1. Similarly, you can consider that port 3 here. Similarly, you can consider that a port 4 here. Okay, so likewise, and then we can calculate that a S matrix for the magic. So now in the case of a this one, the magic T here, since this one is a 4 port device, so what are the component here? The components are what? S11, S12, S13, S14. Then S21, S22, S23, S24, S31, S32, S33, S34, S41, S42, S43, and a S4. So earlier, if you might have seen that, so for the S matrix here, so these diagonal elements are 0. Okay, S11, S22, S33, S44 are a 0. Now this becomes a 0 because since the port is a matched one, so this terminal is going to be 0 there. And then we have seen that if we provide the input at a port 1, okay, since we say that the device is a reciprocal 1, okay, device is a reciprocal 1. So in that case, if we are providing the input to the port 1, okay, if we are providing the input to the port 1, so what will happen to the port 2 here? Okay, so in that case, for a reciprocal condition, S12 is equal to S21 or S13 is equal to S31 here. Okay, so these are about the condition. And generally we say that a diagonal elements are in 0 here. Okay, and then we can find out another parameters of the S matrix, and using the unitary property or using the H0 property. So now in that case here, we say that this one is supposed to be, I am going to calculate that a this row now. Okay, S12, then a S13 and a S14. Okay, so likewise. So what about the this particular parameter? Suppose I am saying that I have the input at a port 1. Okay, I have the input at a port 1 and the output is measured at the port 3 here. So in that case, a S matrix, so that in that case, that S matrix will be what? S3, 1. Input at a port 1, output at a port 3 here. So in that case, it is about a under root of a V3 1 divided by a V in. So we'll get that S3 1. If supposed to be consider that a put at a port 1, so we'll get that V2 1 by V in. Then S4 1 is equal to S14. Okay, is equal to what? V4 1 by V in. Okay, 1 S4 1 is equal to V4 1 by V in. Then okay, then I again write here S2 3 is equal to V2 3 by V in, and S4 3 is equal to V4 3 by V in. Okay, so likewise. So this one we will get the equation. Okay, so now we consider here this particular parameter. We supposed to find out that S31. So we'll get that through this. We'll get the S31 value. Okay, we'll get that S31 value. If you consider that S21, we'll get that S21 value. S41, get that S41 value. Then S43 we are getting. Then S23 we are getting. S43 we are getting. Okay, so like so now remaining parameters. So we can calculate. Okay, using that a condition of a magic team and all other components we can calculate directly. Or if you use in a laboratory, so directly we consider that one here, we measure this one. So all other parameters 1, 2, when we say that input to the 2, output at 1, input to the 3, output at 1, input to the 4, output at 1. So similarly, we are able to calculate the all other parameters. Okay, that is about a measurement of ES parameter matrix. So this measurement, if you consider that, we say that that is to be done. In that case, we supposed to consider that a device, whatever we are using, so that device is to assumed to be a ideal one, and it is a reciprocal with a equal arm length. Then and then we are able to measure the S parameter of the device. So that is about what we can say that a measurement here, micro measurement. So in a micro measurement, we have seen that a measurement whatever the micro bench component. We have seen that a measurement device, that is standing wave detector, tunable detector, match transmission, that we have seen. Then we have seen that a microwave power measurement. We have seen that a frequency measurement, Q measurement, attenuation measurement, then VSWR measurement, phase shift measurement, impedance measurement, and a S parameter measurement. So that's all about a microwave measurement topic. And we supposed to consider that the ideal component in a laboratory there. In a laboratory, most of the sources they are used, it has a reflex restaurant present. Or we supposed to consider the gun diode. So mostly all the setup, all the measurement topics, people are using a reflex restart because it has a 1 kilohertz of a source, and that 1 kilohertz of a source, it is just like a modulated one, and through that we are able to obtain that guide wavelength, and we are able to obtain the impedance and everything. Okay, so that's why a reflex restart will provide the 1 kilohertz of a modulated in output there. If supposed to be we are using a gun diode there, gun diode is just like act as a oscillator. So along with we supposed to consider a pin modulator. So we'll get the modulated output using the pin modulator. So that's why we can modulate the 1 kilohertz signal through the gun diode to modulate a signal that source is of a reflex system. So we can use a source that is about a gun oscillator with a pin modulator. So that will get the modulated output. And that signal is propagating through the microwave range for the measurement purpose. So with this, we stop here. So thank you all of you.